How do we track space junk in geostationary orbit, GEO? Imagine a busy highway in space where satellites seem to stay still above the same spot on Earth. That's what geostationary orbit looks like. About 22,000 miles above us, satellites orbit at the same speed as Earth spins. But what about the debris floating around there? How do scientists keep track of all those tiny pieces of space junk? Well, it's a mix of clever technology and smart strategies. Ground-based radar systems are one of the main tools used. These radars send out radio waves that bounce off objects in space. When the signals hit debris, they bounce back to the radar station. But in GEO, this gets tricky because the distance is so far. The radar signals weaken over the long distance, making it hard to detect small pieces. Still, radars are great for spotting larger objects, like pieces of old satellites or rocket stages. To see smaller or fainter debris, scientists relying on powerful optical telescopes. These telescopes have huge mirrors and sensitive sensors that can pick up reflected sunlight from tiny objects. For example, the United States Space Force uses the Space Surveillance Telescope, which can scan wide areas of the GEO belt quickly. It can detect objects as small as a few inches across, even if they are very dim or have low reflectivity. The data collected from radars and telescopes is combined into detailed catalogs. These catalogs are maintained by networks like the United States Space Surveillance Network. They use the data to calculate the orbits of debris pieces and predict where they will be in the future. This helps prevent collisions with active satellites that provide us with weather data, communication, and GPS. Most debris in GEO tends to cluster around certain longitudes because of gravitational effects from the moon and the sun. This makes tracking a bit easier because scientists know where to focus their efforts. Since many debris pieces are too small to track all the time, scientists estimate their numbers by counting brief radar detections and modeling how debris is generated from satellite breakups or collisions. So, in short, tracking space junk in geostationary orbit is a smart combination of high-tech optical telescopes, radar systems, and orbital modeling. This teamwork helps keep our vital satellites safe and ensures the space around Earth stays as clear as possible.